Well, welcome back to class, as I said. Thank you for coming in on the day before Thanksgiving. I do have a few announcements that I think are probably you'll like. They basically have to do with me giving you points. Okay? So first and foremost, we're supposed to have 5 quizzes in here. We've had 3 up to this point, so I could try and squeeze 2 more in, but that doesn't really seem very nice. So what I'm going to do is, first, I'm going to give everyone full credit for a quiz. So when you look on Blackboard, you'll see, oh, I don't know what I'll name it. I'll probably name it like freebie quiz or something. And then everyone will get full credit for it. Okay, so don't be surprised when you see that. I will still drop a quiz out at the end. So drop the lowest one out as I planned and everything. But that leaves us with 1 more to do. And I'm going to tell you now it's going to be after break. So would you guys prefer to have the quiz on Tuesday or Thursday next week? Thursday? Okay, Thursday it is then. So we'll have our final quiz on next Thursday then. Okay, so that way you can be aware of that. I was going to give the quiz today, but yesterday's class I didn't get them in time, so I just gave up on that idea, and I'll push it until after Thanksgiving. Okay? So there you go. So that's the first thing. You'll get a freebie quiz and then also the quiz on Thursday.
So that's the first, right?
Yeah, I have no idea.
Yeah. Yeah, it's the first.
First?
Mm-hmm.
Cool. Okay.
And that's out of 50?
It will be it'll be scaled to 50. I mean, it won't be 50 questions or anything. It'll just be the normal 3 questions.
No point.
Points, yeah. Okay, the other thing is at the beginning of the semester I talked about taking attendance and so forth. I know today is not the best day to discuss attendance and so on, but I do commend you all for coming in and so on. And for that reason, what I'm going to do is give full attendance to the class because of the fact that you guys, attendance has actually been really, really good this semester as a whole. So I don't see any reason to try and dock you points or anything at this point. I think you guys have earned your attendance score through the semester. So to make my life easier and your guys' life easier, I'm just going to give everyone the points for attendance. Again, I don't think you're going to argue with me about that. If you would like to, please feel free, but I think you may be booed by your classmates. I've never actually had anyone booed in class. I wonder what would happen. I had like verbal fights break out before and stuff.
Over chemistry?
Yeah, I know. It's hard to believe. We were discussing, what were we discussing? I think it's like genetically modified food or something. And people were very pro and con, if that makes sense. And words were exchanged. But that's the weirdest I ever got, I think. Okay, so those will be taken care of as soon as I get a chance as we go on. Now, in terms of the rest of the course, we have, counting today, 3 lectures left as I count them. So we have lecture today and then 2 next week. Now, we do have 2 more class meetings. The Tuesday after next Tuesday, so 2 weeks from today, will be our last exam. And that will cover whatever we cover. Now, I have a feeling that that is only going to be the nuclear chemistry chapter. Okay, so that will be the last portion of it. So that will be Tuesday. Thursday of that last week of class, you will, okay, so Tuesday would be the 6th, will be the last exam. Then on the 8th, you'll get that exam back, and that day will be set aside completely for reviewing. And we'll review everything from the first day to the last day because the final exam will be comprehensive as we go through.
What day of the week is the final exam on?
I'm 99% sure it's Thursday,
Okay.
actually. This isn't my normal slot for a lecture, so I'm not 100% sure, but I believe it's Thursday. Actually, let's just look that up real quick. I don't want to be wrong about that. Okay.
Will the final exams be like on the days that you have classes? Like if
Not
you-
always, because they run 2 hours, and because of that, if someone had, say, a 9 to 10 and a 10 to 11,
Yeah.
they can't be on the same. Now, normally what would happen if it's like a Tuesday, Thursday class is one would be on Tuesday and one would be on Thursday.
Okay.
But I can't guarantee that's always the case. Okay, so final exam schedule here. Okay, so our class is 10:50, Tuesday, Thursday, so our final is going to be at 10:10 on Thursday. So it'll be significantly earlier than our normal meeting time. So 10:10 on Thursday, the 15th, is when our final for this class is. If you need this chart, you just go to NKU calendars, and like the pull down is calendars and so forth, and it's the exam schedule, and it'll tell you when your exams are. There are a few that aren't on here because some classes fall at weird times. This is not one of them. So if you can't find something, just ask your professor, and they should know. Unless they're like me and they just don't pay attention to these things. Okay. So there you go. And any other questions? Yeah.
The extra credit that you talked about last class, what day is that due?
I don't care. When do you want it to be due?
The last day of class?
There you go.
Or the final?
Last final, not a problem. I would ask, actually that's a good point to bring up, not just with that, but in my mind, this course ends on the day of the final. So Thursday, the 15th of December will be the last day for you to do work in this class. So if you're trying to redo homeworks, if you're submitting late work, you're doing extra credit, any of these types of things, think of it as the day of the final is the last day. Okay? I'll go until midnight there, but that will be the last day to submit stuff. Okay. Yeah.
I didn't check this on Blackboard. Did you
Okay.
say that we were going to get full credit for, was it chapter 3's homework? Because there were some wonky questions on there.
A lot of the homeworks are actually pretty hard, like,
Okay.
if you, I don't know, like, some of the questions I'll be looking at, like, when I'll be trying to do them before the test,
Mm-hmm.
they're literally, like, stuff I've never even heard of before. Like, some of the questions, I mean, there's some questions that, like, we have learned, and there's some
Mhm.
questions that's just, like, it's foreign,
Yeah,
pretty
they're
much.
really tough. I think they are.
I don't know if you looked at them or if you saw them or
I
anything,
did.
but
Man, well, okay, I chose them all.
they're pretty tough.
There's a database that I'm using that's got a couple hundred questions for each chapter, and then I go in and I choose the ones out of it. And obviously that's not, well, not obviously, but that's not my intent by any means, but it's quite possible that that's the case.
Have you do them?
I'd be trying.
So-
They be hard, yeah, they're hard, like.
Yeah.
You'll have to do it a couple.
For 25 questions, it takes you about an hour and a half to answer them because they're so hard. I'm not
I'm
even
just
joking.
two of the tests so far. I haven't tried. How many tests have we done? Like 5, right?
Probably.
Yeah, I haven't tried it, but the first 2 are hard.
Okay.
I tried the first chapter 1 through 4. And I just stopped.
I just remember somebody said something was wonky about it. And
There was one, but I think I've adjusted the score there. I'll go back and look.
I didn't know if it was I didn't know if it was chapter 3.
I don't
Oh, yeah,
remember
and
what chapter it was.
Sometimes,
And then sometimes the answers actually are right, and they still say that they're wrong. I'm serious.
No, I don't doubt you at all.
Because one
It's-
time I
it's
got the question,
possible.
I got the same question multiple times, and I literally tried every single answer
Yeah.
except every single one was wrong. Every single answer was wrong. I'm
Okay.
not joking.
Yeah.
We all did it together.
All
All
right,
of us.
so if that occurs, just copy paste it into it's a little late. Copy paste it in an email and send it to me so that I know and I can make the corrections for it. And I would obviously give you the points for that question and stuff as long as you, it's like the newest trial that you're doing, and so forth. I'll take a look at it though. Okay? I know.
Those homeworks are stressful.
I know they're not perfect by any means. And they can be improved upon. Fully aware of that. And The problem is, I'm not sure that that helps you at this point. And I don't know a way. Let me think about it, okay? Let's say it this way, your complaint is noted and will be thought about, okay, to see if there's a way that I can help you out. Because by no means do I mean to make them super hard. I don't mean them to be really easy either, but it is possible that it's too much on the difficult side. So an adjustment would need to be made there. Okay? And I'll think about what that could be. There you go. Anything else? Thank you for bringing that up, by the way. I know it seems like I don't necessarily.
I meant to bring it up a long time ago,
Yeah.
but I forget literally every class.
I do too. Yeah, so let me think about it. Okay, anything else going on? Okay, I guess with that then, what we're going to do is jump back into lecture itself. And last time we were doing some half-life problems and we did several of them. Does everyone feel fairly comfortable with the half-life at this point in doing the problems and so forth?
I had a question about
Yeah.
the half-lives.
Mhm.
On one of the homework questions, it asked you to calculate the duration, the time frame.
Okay.
And then it also asked you to calculate if you started out with like 25%,
Okay,
and they want to know what you began with.
okay,
So the way I did it was different than how they did it in the thing. How I started off with was 25%, and then I moved backwards
Mhm.
to get the full amount. Can you do it that way on an
yeah.
exam?
Mhm. Oh yeah, absolutely.
Okay.
Absolutely. Just to remind everyone, you can absolutely do that. I'm not, this is what I'm trying to agree with. When you're on an exam, since we're all coming from different backgrounds, especially chemistry backgrounds in this course, if your answer is right, it's always going to be right. It doesn't matter how you got there. Well, unless you copied off somewhere. It's going to be right, however you do it. Okay? So if you just have a different method for doing something, then by all means do it as long as it works and so forth. Okay? Now, if it comes to partial credit, as long as I can figure out what you're doing, and in this case I would totally know what you're doing, then you would still get the partial credit even if it's not completely right. But if, for example, you drew a circle and then you had like X's coming, I had no idea what it was, then I wouldn't be able to get partial credit. So in your case, yes, absolutely. However you want to do it is perfectly fine. Okay? And that, is an important point with 2 exams coming up. I just wanted to mention it again. Okay, so half-lives we've talked about, and the idea of half-lives being the rate at which materials decay. Now, if you plot half-lives and their decay curves, what you're going to see is this. So this is iodine 131, and it doesn't particularly matter that it's actually iodine in any way, shape, or form. I just want you to see the curve. What you see is you start out with a very, very quick drop-off. So when you have radioactive materials, at the very beginning, they decay very quickly in terms of their amounts. But it takes a very, very long time for it to actually get to what we would consider safe levels. So if you have large amounts, for example, you may have to go out 30, 40 half-lives in the amount of time. Well, this one, the half-life is 8 days. So if you're going 30 half-lives out, you're looking at about a year, right? 240 days, or whatever it is. And that's how long it would take for iodine 131 to break down. Iodine 131 is an example of one of the materials that was released when the nuclear meltdown happened in Chernobyl. So they were concerned about this. So some of this material was released in the atmosphere. How long would it be dangerous in the atmosphere, and so on, as you went along. If we looked at nuclear waste, for example, nuclear waste, one of the radioactive isotopes is unreacted uranium-235, which is 7 times 10 to the 8th years. So if you're looking at 20, 30 half-lives there, it's going to be 20, 30 times that long. Okay? That's an incredibly long amount of time to think about. Okay? In here, we've talked a little bit about Yucca Mountain, right? The U.S. plan? No, you guys all look at me. Okay, it must be my other class. Yucca Mountain is the plan for the United States to deal with nuclear waste. Okay. Has anyone ever heard of this at all? Yeah? Okay. So do you know where it's located? Nevada. It's in Nevada. And basically the plan of the United States for radioactive waste is to take it from all the different nuclear power sites and places that produce it and then move it there and bury it in the ground. Okay. And there's several problems with this, one of which I personally believe burying it in the ground is not a good solution. Okay, we've tried that before. After we made the nuclear weapons we used in Japan, the byproducts of that were buried in the ground, and they're at the most contaminated sites in the world right now. They're called Superfund sites. They have special names for them. They're so bad. Now, if I didn't talk about Yucca Mountain, I didn't tell you about Superfund sites either, did I? So these are the places where they worked on making the nuclear weapons. They took the radioactive material and buried it underground. And they thought, okay, we'll be smart about this. We're going to take the radioactive material and put it inside metal barrels, and then we'll seal them closed so they won't just pop open. Then we're going to encapsulate the whole thing in cement, and then we bury it in the ground. And that's what they did. Well, what happens to sidewalks when you have trees close by to them over time? They crack, and roots get into them and break them apart and so forth. This is exactly what happened with these buried things. The roots of trees got into them and started cracking them, and they cracked through and so forth into the barrels, and then groundwater went into the cracks. What happens when you mix a metal barrel and water? It rusts, right? So now you've got water running into this. It rusts holes in the metal barrels, and then the water runs right through the nuclear waste and then out the other side. This is what's happened at all of these sites. So they have large amount of radioactive debris now dispersed through the ground thanks to the groundwater and so forth. It may not sound like a big deal because it's buried in the ground, but then the plants will actually grow and accumulate that radioactive material in the leaves and so forth. Yeah?
Okay, so what is the alternative for not putting it under the ground? Like, what can they do to get rid of the nuclear waste?
That's the million-dollar question. Okay, so there's a few things. In most countries in Europe that make nuclear waste, they recycle about 97% of the nuclear waste back into the power plants and so forth to use again and so on. So they only have basically 3% of the material going to long-term storage. It's very expensive to do, so companies in the United States don't want to do that. So they don't generally. There has been plans. Well, there's been a lot of plans. There have been plans to sink it to the bottom of the ocean. Again, okay, none of these are good options, by the way. Oh, that's one of the better ones, actually. There was one to gather up all the nuclear waste and put it on a barge and just ship it out to the ocean somewhere so that we didn't have to deal with it.
Yeah, send it to space.
Send it to space. That's a popular one as well. However, what is our track record on successfully getting things into space? Okay, I mean, it's not horrible by any means, but I would say 5% minimum explode on the way to space. Okay, so like satellites and things when they're taking off and so forth. So imagine if you've got a bunch of nuclear waste, it's up in the atmosphere and then it explodes. That's going to get spread all over the place. Okay, so that's not really a good solution. If we could get it to space safely, that would be an option. But even getting out of Earth's orbit, the Earth, no one ever really talks about this very much, but the Earth is surrounded by satellites and stuff, and also junk material from old satellites and so forth. So if you ever look at like debris around the Earth, you'll be amazed by how many things there are circling the Earth at this point. So you'd have to pick the right trajectory to get out as well, and so forth. It can be done, but there's a lot of dangers involved there. So generally, they don't like that. Just the idea of transporting it to Yucca Mountain causes problems. So say Oak Ridge. Oak Ridge, Tennessee is one of these sites that makes radioactive waste. So it's got to go from Tennessee, just outside Knoxville, to Yucca Mountain in Nevada. How does it do that? How are you going to move it from one place to the other? Probably not a plane, right? Because you're concerned about plane crashes for the same reason we're not shipping it into space and so forth. So you're going to use trucks, okay? Trucks are going to have to use roads or train. I guess you could use train and use train tracks. But where do roads and train tracks in this country go from place to place? What are at the ends of the places? Cities, right? Roads run from city to city. Train tracks run from city to city. So then you're taking this radioactive waste and you're transporting it through cities. Imagine, heaven forbid, if someone blew up one of the trains inside of a city. This is a concern, right? And people raise this concern. Now, we do actually have radioactive waste that travels on our roads in relatively small amounts now, but the concerns is how would we get it there? That's one of the concerns. Yeah?
They don't have anything that can neutralize it?
No. No, the only thing you can do to neutralize nuclear waste is wait it out. Which, in terms of uranium here, for example, I'd be surprised if well, I know we personally won't be around. But we're talking billions and billions of years for this. And this is one of the things. Even if we get it to Yucca Mountain and we bury it, right? Let's assume none of the other issues happen. We get it to Yucca Mountain and we bury it. Now that place is incredibly dangerous for 1 billion years. That leads to all kinds of questions. Like, for example, when you want to make a warning sign, what do you write on it?
Warning or caution.
Okay. What language are you going to use?
English or Spanish.
English or Spanish? And do you think that's going to change in 1 billion years? Right? I mean, it's probably not going to be the same language. If you look at English, for example, Old English, which is at most 500 years ago, most people can't understand it now as it is, let alone thousands of years. Yeah.
Okay, so when they bury it, are they doing it to like no longer use it or just to preserve it?
To no longer use it,
Okay.
to get rid of it. Okay. So, and then security for it. I mean, the American government, is the American government going to be in charge of the space for the next 1,000 years? Who knows? We like to think the American government would be around forever, right? But, you know, it's only a couple hundred years old at this point. So you never know. So there's all kinds of interesting things. A lot of people spend a lot of money trying to figure out what types of signs to use to make warning, like, so people understand it. They went with pictures, by the way.
X's on the eyes and maybe a frown.
Yeah. Yeah, there's no good answer there. I just don't know. So that's the U.S. plan. However, that plan is on pause. Congress a few years ago said that's a dumb plan. Don't do it. And then the courts threw out that law because they said you can't just say it's a dumb plan. You have to give an alternative. You have to have some sort of plan. And they're like, well, there's no good plan. So what Congress ended up doing was keeping Yucca Mountain, so they followed the court's ruling. That's still the United States plan, except they give it $0 a year right now in the budget. So nothing's happening there. Nothing's happening at all.
So then what are they doing with all their nuclear?
They're storing it at the individual sites. So every place where it's made, they're storing it there.
How much is like produced? How much waste is there?
I don't know. I don't have the answer to that. I'm sure you could Google amount of radioactive waste produced in the U.S. a year and you'd find out.
Are there like a lot of countries that use nuclear power, or is it just?
Yeah, oh yeah. Oh yeah, there's a lot of countries that do. And no one's really got an answer for it. Now, I do want to say, just so everyone's aware, I am actually pro-nuclear power. Pro-nuclear power versus coal power. I think nuclear power is a step in the right direction instead of coal because it's not emitting all the gases to go everywhere. It's kind of localized. That's my view, but just so you guys are aware, that may color
But then
my
you're like putting it
discussion.
in the ground, it just seems like so environmentally.
It is. It is horribly, but in my opinion, again, when you're burying it in the ground, you are destroying the environment in one location. When you're releasing fossil fuel waste into the atmosphere and so forth, you are destroying the environment in most, if not all, locations.
It's like a lesser of two evils, it's just so.
Yeah,
Yeah.
I think so, in my opinion anyway.
Yeah.
But aren't they gonna run out of, I mean, you can only house so much stuff at one site. I mean, it's gonna come to a head where.
Oh, yeah, absolutely.
I mean, yeah.
At some point in the future, we're gonna have to deal with it.
Right.
And it'll probably be in our lifetime. How we deal with it though, I have no idea. I mean, I would hate for us to start shipping our nuclear waste to other countries for storage, just to get rid of it, like we do electronics waste and stuff. But that may be what happens. People in Nevada actually want Yucca Mountain to run. They want it there because they want the jobs and they want the economic impact of it and so forth. So, you know, there's two sides to every story in terms of that. But if you live close by and you don't have a job and the government's coming in building this huge facility and saying we're going to hire hundreds of people, like good government paying jobs, that's a pretty big pull for you without worrying about what's going to happen 1,000 years down the road. You know? So we'll see. We do know from the past, though, it doesn't work out so well. So like Oak Ridge, for example, where they buried it, if you hunt deer, for example, anywhere near Oak Ridge and you kill a deer, before you can get it butchered, you have to take it to a special place where they measure the radioactivity of it to make sure that the meat in the animal is not radioactive. It's pretty nuts. You can take a leaf from a tree and hold it up to a Geiger counter and it'll send it off the scale. The biggest story I heard is they were doing some construction in Oak Ridge, and I worked there for a while, is why I know the stories. They were doing construction for a while, and whenever a construction truck would go into the radioactive area or back out, it has to be scanned for radiation. So this truck went in and it was scanned, and it was perfectly clean, and it went in, and then it came back out and they did the scan, and they found a huge amount of radiation in one of the wheel wells. And people are like, what's going on? They were looking for leaves and stuff, and there wasn't any leaves stuck there or anything, so they couldn't figure it out. And eventually they figured out what happened was the truck ran over a frog. And the frog itself was radioactive enough that it set off the alarms on it. So the US government, in their infinite wisdom here, being sarcastic, what did they do? Well, they can't let the truck leave because it's now radioactive. So they bought the truck from the guy, dismantled it, put it inside of a container and closed it, and then buried it in the ground. So there's just no good answer to this problem. And when we talk about nuclear power and nuclear weapons and so forth, this is one of the major things we got to think about when we're talking about it. What do you do with the byproducts? Okay. I don't know that there's a good answer there. Have you guys heard of what's called a dirty bomb? So a dirty bomb is where you take radioactive waste and put it with a conventional explosive. So say you've got a container, it's full of radioactive waste and then a normal explosive inside of it, so when it explodes, it spreads the nuclear waste all over the place. It's called a dirty bomb, is the name of it. And people are really concerned about this inside of big cities. So imagine if someone went in Times Square and set off a dirty bomb and radioactive waste was spread all through the air and then people inhaled it and so forth. This is a problem.
But couldn't they do that with just the nuclear sites that have it, I mean, just set a bomb off there? I mean, it would release everything that's stored.
Yeah, so a nuclear bomb itself, it would be much, much more difficult to get a hold of. I'm not saying it would be impossible, because number one, I would have no idea, it's not my world. But the radioactive material you need, say uranium-235 and the concentration you would need to actually set off a nuclear weapon, would be very difficult to get. Where a dirty bomb, and the reason they're concerned about it is because you could go to any nuclear power site and steal this byproduct and then use that.
But aren't the facilities guarded?
They are.
Okay.
They are, but again, you know, there's, I want to say like a dozen, 15 in the US. There are hundreds around the world that you could theoretically go to and steal some from. When I was in Oak Ridge, actually, someone tried to steal uranium-235, but they only got like 5 feet before they were arrested. Because they've got sensors that measure the radioactivity, so if you try and go out of a building with anything radioactive, it sets off the alarms. And then when you get out, they have the fences set up, so they run parallel, and you go out, and then you've got to walk like a block down, and then you go 5 feet forward, and you got to walk a block back. So after walking 2 blocks, you're literally like 5 feet on the other side of the fence to get out. So when they stole it, they had to try and run that. They didn't get anywhere in terms of it. So there is security for the stuff, but that being said, it is a concern that's cited many, many times. But just dealing with it is going to be an issue. Comments about that? Nuclear power is actually fairly common in the world around us, especially in countries that don't have large amounts of natural resources. So, yeah, we'll talk about that a little bit later on. But you got to deal with the waste, and that's what started this whole conversation. Yucca Mountain is interesting from a political point of view, and whether or not you support it or not, and various things. There's a lot of different sides to it.
So could somebody win the Nobel Prize if they figured out the answer to how to dispose of it?
Oh yeah, yeah. You wouldn't be worried about the Nobel Prize. You would just, I guess they'd give it to you as a formality. If you could figure out how to safely dispose of nuclear waste, that would be like inventing unlimited power. There would just be no limit to what you could do. The Nobel Prize would be a tiny fraction of it. You would be famous in every newspaper in the world within minutes. So, yeah, go out and do that. And when you figure it out, tell me, so that I can be rich too. There are people who spend their entire lives and billions of dollars trying to figure out how to reduce the amount of nuclear waste by 1%. So government would literally throw money at you till the end of your life if you could figure out how to just decrease the amount of nuclear waste a little bit. But that being said, yeah, it's just, if you could do it especially cheaply.
So why don't they do like, what was it you said that?
Recycling.
Yeah, why don't they do
Recycling.
that?
Well, because it's left up to the companies, and it's cheaper to just currently store it than to actually recycle it and so forth.
Okay.
I guess at some point in the future, if recycling becomes a more economically viable option, then they've got all this material they could recycle and use it at that point. But for now, it's just not worthwhile in the US. Other countries require it by law, so they're forced to do it there. So that's the reason. Okay. Any other comments or anything? Okay. So I've got another example I want to talk about. This one actually has to do with half-life. And this is called carbon dating. So carbon dating is carbon-14. It's a radioactive isotope. And this radioactive isotope is present in all living things. So everything that's living on this earth has their structure based on carbon. This is what makes it really, really nice. So you can actually use the carbon that's incorporated into living things to figure out how old it was, how long ago something died. Okay. Now, this is used in archaeology all of the time to figure out how old things are. You'll hear it called radioactive dating or carbon dating is probably the more common name for it. but you'll hear it by a variety of different names. And it's all the same thing. But it's basically using the half-life of carbon to figure out how long ago something died. Now, this something could be a tree that they're burning in a fire pit. It could be a tree that they're making a house out of or a carving out of. It could be clothing. Cotton, for example, up until the last 100 years, all clothing was made with natural fibers. So you could test those natural fibers and actually figure out how old something was. Shells can actually be done this way as well, or the material round shells and so forth. So there's a lot of different options. So this is a really, really powerful technique. We all are familiar with it, even if we don't know it. When we say this archaeological pot, when you go to the museum and you see something in the museum and there's a date on it, that's most likely done through carbon dating, if it's a natural product in any way, shape, or form. Metal bowls, those types of things you can't do carbon dating of. You can do other types of dating, but since they don't have carbon in them, they won't work. So when an archaeologist finds something, one of the very first things they do actually is carbon dating to see how long it is. Carbon's half-life is about 5,700 years. And because of that, you can measure about 10 half-lives back. So you can go about 50,000 years back into history. Now, if you're thinking about humankind, how long has human society, or at least recorded human society, been around? Probably not more than 5,000 years, 10,000 years at most, somewhere around there. You know, if we think it's 2,000 now, so go back 2,000 to 0, and then ancient Greek and stuff was like 2,000 before that. That's 4,000 and so forth. So you're not getting anywhere near the 50,000 limit in terms of what's actually done with carbon dating. Now, carbon dating itself works in an interesting fashion. The reason that it works is because carbon-14 is made in the atmosphere. So let's imagine we've got our Earth, my handy-dandy drawing today, and up here in the atmosphere, carbon-14 is produced. The way that it's produced is cosmic rays run into a nitrogen atom. They react with a couple different things at the nuclear level, and carbon-14 is made. So this is always occurring. And in our atmosphere, we have a certain amount of carbon-14. There's a certain percentage associated with it. We don't really care what it is, but it's constant. So we always end up with roughly the same amount of carbon-14 in the atmosphere at any given point. Now, we have living things. So let's use, for example, a tree. And when that tree is growing, it is taking in carbon dioxide to grow. So this carbon-14 is getting incorporated into the tree. And as it's growing, at the same time, old carbon-14 is decaying. So when the tree is living, the carbon-14 amount is constant. So basically, the amount that's decaying out is getting replaced all of the time because of the fact that it's taking in carbon dioxide. And that carbon dioxide has carbon-14 in it. So it's made in the upper atmosphere, and then the tree takes it in and gives it a constant amount. That's how carbon-14 gets into the tree. Now, when the tree dies, let's say it's cut down. Can't really draw it, so I just put a zigzag here. And the tree dies. It stops growing. It stops taking in carbon-14. So your carbon-14 amount begins to decay. So since it's not replenishing it, it's constantly then decaying down at a given amount. So the minute the tree is cut down would be age 0 here. You're going to be giving off 100% of the normal carbon-14 amount. Then as time goes by, that amount is going to decrease for every half-life or every amount of half-life. Yeah?
Okay, so we're trying to figure out when exactly it died or how old it is.
When it dies.
Okay, so but
Yep.
just a quick question.
No, of course.
I heard it's probably wrong, but can't you see how old it is by counting the little circles within
Yeah.
the tree?
Yeah,
Okay, yeah,
the rings in the tree, that's completely true.
Okay.
So that is used to like figure out the age of a tree. This would be used to figure out how long ago a tree was used, or how long ago the tree was killed, actually. So if, for example, it's 2,000 years ago, and you want to cook something, you're going to need a fire for that. Okay? So you find some wood, you burn your fire. Okay? Then archaeologists come along 2,000 years later, they look at where the fire was, they take samples of it, and then they can figure out how long ago that tree was cut down. The same goes for buildings. You know, if there's a building and they find pieces of the building, they can date how long ago the tree was killed and so on. Clothing, cotton's the same way. Find a scrap of cloth, you can actually date the cloth because the carbon in the cotton stops when the cotton's picked. Okay? When the cotton's picked and then weaved into a cloth and so forth, you can figure out how long ago that was. So if it was 5,000 or 5,730 years ago, 5,730 years ago, you would have half of the carbon-14 and then so forth and so on coming out of it. You don't need a full half-life to measure it. You can measure as little as, say, 50 years as you're going along. So it wouldn't be 100%, it'd be like 97% or whatever as you're going along. And that's a math formula to figure that out, but we won't worry about it. Okay? So you can figure out then how old something is by looking at how much radiation is coming off of it. Does that make sense? That's the gist. Okay. My grandfather absolutely refused to believe this. I would argue with him for years about this. I'd be like, Grandpa, this is what happens. I have a PhD, trust me. He's like, no, it's not true. It is actually what happens, by the way. You can do experiments with half-lives and watch this over and over again. I don't do it with carbon-14 because the half-life is so long, but there are other isotopes that have a half-life of like a minute. And then you can see it drops halfway every minute as you go through. Yeah?
So the way to decide how long it's been, I guess, dead,
Yes.
is
Would be a good way to say
because
it.
the carbon-14, it decreases, the amount decreases
Mhm.
because there's nothing being replaced?
Yep.
Okay, okay.
Yep. No, that's exactly right. Yep.
I have a question.
Of course.
I had heard something similar to that about like Mount St. Helens volcano erupting,
Okay.
and then the ashes fell, and then they did carbon dating on it, and it said it was a lot longer, even though they had watched it settle in like rude days. Do you know anything about that?
I do not know anything about that. However, I would speculate to answer the question in terms of this. The material that they're doing wasn't, like the ash wasn't created at the explosion. That ash and material is actually much, much older because it's part of Mount St. Helens, but we didn't visibly see it erupting until the time period.
All right.
So when, say for example, the stone was made, if that makes sense, that would be the time period where it starts to decay. Because you don't have a constant replenishment in like wood and stone and metal and so forth. It's when it's made itself, not when you see the event. That would be my explanation for it, but I don't know the specific case. So yeah,
So with stuff like this, you'd obviously be working backwards.
you would be
So
working
once you take your
backwards.
sample and you find out how much carbon's in it, you would find out what the half-life rate is, and then work your way back till you get to 100%.
Yeah, so the way this works in real life is you find your sample, you put it in the instrument, you measure the amount of radiation coming off of it, and say, okay, there is 82% of your normal amount of radiation. So then using that, you then go back to figure out how many years that has been. And there's a math formula, it's not particularly hard, but we don't care to do that. And then you can figure out how long ago that was taken from. Yep, and this is by far the most common way to date archaeological finds. It's really easy to do, actually, in terms of that world.
Is that how they find out like dinosaur bones and all that kind of stuff? They say,
Yeah, so dinosaur bones is one thing that you can do. Now, dinosaurs, they don't actually do carbon. They'll use a different isotope, but it's the same general idea. Recently, they found several English kings that have been buried. It's for whatever reason, they're building parking lots and they keep finding these bones of English kings in random places. but that would be another case of measuring bones and so forth. And there, you could use one isotope on the bones, I think it's calcium, on the bones to do, and then like the clothing that they're buried in, you could carbon date and then see if they match or not from the ideas.
So will this be on the test and most likely not?
The ideas will be on the test, like explain the basics of it, not so the exact cases like English. However, I will say I would like you to know at least the basics of the story of my example here. So this is an image. It's a very small image of something called the Shroud of Turin. Has anyone ever heard of the Shroud of Turin before? Okay, a couple people. So before we get too far into the discussion, again, I need to do a disclaimer. I was raised Roman Catholic. I went to Catholic grade school all through 8th grade and so forth. My family is actually very religious. I am not. Okay, I'm not religious in any way, shape, or form. So take all that with a grain of salt from the story. But the Shroud of Turin, this is a piece of cloth. It's 4.5 meters long, so it's relatively long. 4.5 meters would be about between 13 and 14 feet long. Now, it is an old cloth, but what makes it particularly interesting, and actually a holy relic, if you're familiar with the story, is the image that's on it. So on this cloth, there's actually an image, and this image has some very characteristic features to it. There's an image of a man. The man has puncture wounds in his hands and his feet. He has a very large wound in his side, and he has multiple small wounds across his forehead. Now, with that in mind, and taking that I was raised Roman Catholic and it's a holy relic, who do you think people believe the image is of?
Jesus.
Jesus. Okay. So the Shroud of Turin is believed by the church to actually be the cloth that was placed over Jesus' body after the crucifixion. So the story according to the Bible is Jesus was crucified, and therefore he had the puncture wounds on his hands and feet, the crown of thorns, giving the marks on the forehead. And before he was taken down, I forget his name, but one of the Roman soldiers put a spear through his side, and that's the wound on the side. He was taken down, he was placed in the tomb, and a cloth was placed over his body. Then, if you're familiar with the story, after 3 days he rose from the dead, and this cloth was thrown aside as he rose up. Okay? Some stories say that there was a very bright light that occurred at the tomb at this time, and many people believe that that's when the image was actually transferred onto the cloth. So this is kept in a church in Turin. It's under lock and key. They have a replica they show, but they don't show the original. A few years ago, the Olympics were in Turin, and the news stations wanted to see the shroud so they could show it on TV, and the church is like, no, that's not going to happen. Go ahead and look at the replica all you want, but we're not taking out the original. I think the only way you can see the original is a personal invite from the Pope. I would imagine it would take. So if you can pull that off, let me know. I'd like to see it. I've never actually seen the reproduction either. So here's the whole image. These are actually negatives of it. The original cloth is the tan that you would expect from cotton and so forth. This is the photograph reversed, because when it's reversed, the dark areas become light and you can actually see it a little bit better. So there's a lot of damage on the cloth already. That's what these are. But if you look, here's the face, the chest, the legs, and so forth of the image. So scientists for a long time thought, well, this is perfect. We can test how old this is. This is a cotton cloth, so therefore we should be able to figure out how old the cloth was or when the cloth was made, and we can do that with carbon dating. So church, do you mind if we go pull a few threads out of your relic? And the church is like, no, that's not going to happen. You can't go in and destroy this relic just to prove the date of it. We're not concerned about it. We know that we're right. We know that we're right. You're not able to do that. So this went back and forth for a long time, I think about 100 years. Scientists saying, hey, we can test that. The church saying, no, we're good. and so forth. Until 1988, scientists finally convinced the church to let them test it. And threads were taken from the shroud for testing. They were tested in 3 separate labs. These labs each had different religious affiliations. They had different nationalities, just about everything different you can think of. So that, for example, it wasn't just church scientists testing it, it was people from different faiths and so forth. All 3 labs came back with the shroud being about 800 years old. So if it was actually the burial cloth, then it would have to be, well, 2,000, more or less. Just under 2,000 years old, because that's when Jesus was crucified, where this is showing it as 800 years old. And so it's most likely not the burial cloth because of the fact that the cotton is only 800 years old instead of 2,000. Or so the carbon dating says. This is by no means the end of the story. You can go on like National Geographic or the History Channel and stuff, and they have entire hour-long shows just for this and the discussion of this. So even though carbon dating says that it's not that old, there's a few things that still lead to arguments. For example, nobody can reproduce the image. There are several things unique about the image and different. For example, the coloration of the cloth is uniform through the cloth. So one side doesn't have more color than the other. It's the same all the way through. So if you think about painting an image on something, if you paint one side, right, that side's going to have more pigment than the other side as it soaks through, just from normal drawing through the cloth. That's not the case here. People have been trying for hundreds and hundreds of years to reproduce this, and nobody can do it. Okay, no one's been able to do it. About a decade ago, there was an Italian scientist who thought he could do it, and then it was proven not to be the case. Yeah?
So does it seem as if it's proving that it could be at the time when Jesus arose, or?
Well, okay,
It
so
seems like the time is off, but the way it's made, it seems unique to where they don't really know how it was made.
they don't know how it was made, absolutely.
But the timing is not.
Yes. So the carbon dating says that it's much newer than the age of Jesus.
Okay.
But there are several things that are still up in the air. For example, the reproduction of it. You would think that we'd figure out how to make another one that looks the same. We can't do it. Okay? Now, some people say that the reason we can't do it is because it was done by a technique that we no longer know. There are numerous examples of that in history where science can't explain something because we don't understand what was going on at the time. So for example, there's one type of paint and a painting method that came out of Venice during the Middle Ages where the paint basically sparkled when it's on the canvas and so forth, and no one could figure out how they did it. Okay? Just within the last decade, we figured it out, and it's a really simple thing that no one even thought of. They just took colored gems, like valuable gemstones, rubies and sapphires, ground them up, and then used it in their paint. And that's how they got it to sparkle like they did. Another example of it is Damascus steel. Legend has it Damascus steel was the strongest steel that was ever been made. It's got a very distinct coloration and so forth to it. For thousands of years, people tried to reproduce it and match the samples that we had, and no one could do it. That was due to the amount of carbon in the iron that was used to make the steel and so forth. So there are examples of things that we can't explain to this day. There are other theories on why the carbon dating is wrong. If you go back historically, about 800 years ago, the shroud was kept in a castle, and that castle burned. So one of the theories is that the smoke from the burning of the castle went into the cloth, and we're actually testing the smoke particles. So the stuff that burned, how old that actually was and not the cloth itself. Another concern is the fact that we are actually testing the outside of the cloth because the church didn't want us taking from the center of the cloth up. I say we, it wasn't me, by the way. The scientists taking samples from the center of the cloth, so it may have been a section that was repaired later. Like there was some damage to the cloth and then they repaired it 800 years ago. That's perfectly fine, or some sort of contamination. We don't really know. I mean, in the end, you can believe whatever you want, but there's pros and cons to all of it. Yeah.
So that was obviously a blood stain, right? That made the impression.
Yes. Yes, I believe I was reading about it, and I believe it is AB type.
Okay, well, that
Yes.
was my question. Is there any way that you can, it might be way too old, to do any type of DNA testing?
No. So DNA has not survived. You can go online and look it up, and there's literally thousands and thousands of pages written about this. And then you wouldn't really have anything to compare it to.
Right.
Because back then they didn't really have DNA samples and stuff like that, did they?
Oh, no.
Yeah,
No, they
so,
didn't
yeah.
sample DNA and stuff until the last 50 years. DNA is,
But it was AB blood, though.
yeah, they typed the blood, apparently. Now, granted, I got this from online, but it seems like why would someone make that up?
Right.
Yeah, and you can look at, like, they've looked at the weave of the cloth, and apparently the weave of the cloth doesn't match the process that was done 2,000 years ago. It's a later pattern. So, again, not my area of expertise. So, there's personally, I believe there is more evidence to say that it's not than there is, but it's an interesting case because you can kind of see both sides. Especially when you take into account the smoke and the repair and so forth, that would give you credence to not believing the carbon dating, when the actual science itself of carbon dating is not really questioned. So, I don't know. Yeah.
Is it like uniformly dated, the whole thing? Like if you take different samples from different areas, can it be dated differently, or is it just?
Scientists don't know the answer to that because we can't just go in and pull random samples. Like ideally what we'd like to do is go in and just like probably grid it out and then try different things and so forth and see if it always comes up the same, but the church isn't gonna let us do that.
Right.
It's just not gonna happen. So, in the end, you can kind of believe whatever you want. The other interesting part to the story that's often brought up is about 800 years ago is roughly the time period of Da Vinci. So maybe he came up with the technique, and that's why we can't figure it out, because he was so smart. I don't personally believe that, because the time period doesn't match up exactly right. And also, most of Da Vinci's things, he just shared. But the theory is that he was trying to discredit the church at the time. So take that as you will. But there is, again, some things we just don't understand as scientists. You know, as scientists, we like to believe that we have everything figured out and so forth. That's not the case at all. There's another religious relic that is basically a lantern, and there's oil inside of it, and one day a year, the oil turns red. And then it goes back to clear, and then it's fine until the next year, and then it turns red again. I have no idea at all. Scientists really, really, really want to go stick a syringe in it and draw some of the liquid out and test it. But the church isn't going to let us do that. They believe it's the blood of a saint or something. I don't exactly remember what it is. But there are numerous things in the world we just don't understand. And that's an important thing for us to remember in science. You know, I believe we'll figure them out given enough time. But who knows? You can believe whatever you want there. Okay. Is class over at 5? At 5 after, right? Yeah. Okay, let's end here because I don't want to get into the next topic. It's going to take longer than 10 minutes.
You have a great break.
You too. Everyone enjoy your holiday. Remember, mashed potatoes are the best.
Stuffing.
Share. Stuffing's pretty good. Share with your friends. Pro mashed potatoes.
Do you know when we get our